In this video, we want to look at how we can use our calculator to help us construct t-intervals for confidence intervals for the mean. So let's look at this problem. It says tensile strength is the amount of stress a material can withstand before it breaks. Researchers wanted to determine the tensile strength of resin cement used in bonding crowns to teeth. The researchers bonded crowns to 72 extracted teeth. Using a tensile resistance test, they found the mean tensile strength of the resin cement to be 242.2 newtons, with a standard deviation of 70.6 newtons. Based on this information, construct the 90% confidence interval for the mean tensile strength of the resin cement. Okay, so what we're going to do, first of all, we need to determine that a t-interval is the appropriate type of interval to use. So if we look at our problem, we see that we're asked to construct a 90% confidence interval for the mean. And we know that there are two types of confidence intervals for the mean. One is a t-interval, one is a z-interval. The main difference is for a z-interval, we know the population standard deviation. But for the t-interval, we only have a sample standard deviation. So when we read back through this problem, it says using a tensile resistance test, they found the mean tensile strength of the resin cement to be 242.2 newtons with a standard deviation of 70.6. Okay, what is this describing? It's actually describing the 72 extracted teeth. So this would not be a population standard deviation. It's only a sample standard deviation. So in this case, we can say that sigma, the population standard deviation, is not known. Okay, so that's kind of condition one for the t-distribution. Additionally, we need to know that either the population is normally distributed or our sample size is greater than or equal to 30. And we see that our sample size is greater than or equal to 30. Since n is greater than or equal to 30, we can use a t-distribution. Okay, our formula for a t-distribution is x bar plus or minus t alpha over 2 times s over the square root of n. Okay, x bar in this case is 242.2. Okay, we're going to come back and talk about t in just a second. Our sample standard deviation is 70.6, and our sample size was 72. Okay, we're looking at a 90% confidence interval. So that means I've got 90% of my values there in the middle. Alpha in this case is 10%, and so we have half of alpha in each tail, or 0.05 in each tail. Okay, since I'm using a t-distribution, I need to figure out the t-value that separates this lower 5% from the middle 90% and then from the upper 5%. And so what I'm going to use on my calculator to get this t-value is inverse t. Okay. The syntax for inverse t is going to be area to the left and degrees of freedom. Okay, when we're talking about the mean, the degrees of freedom is one less than the sample size. The sample size in this case is 72, so we'll use 71 as our degrees of freedom. Okay, so let's look at how we can get that t-value using our calculator. I'm going to go to my distribution menu. So second, distribution. Number 4 is the inverse t option. Okay, the area to the left that I want to look at is 0.05, and my degrees of freedom is 71. Okay, and so we get negative point or negative 1.666. We'll just call it negative 1.67. So I can use this as my t-value, 1.67, because we're going to do plus and minus in our formula already. Okay, so on my calculator, we're going to have 242.2, and I'll say minus 1.67 times the standard deviation, which was 70.6, and I'm going to divide that by my sample size, which is the square root of 72. All right, so that gives me my lower value, and I'll just hit second, enter. That brings up my last entry on the calculator, and I can edit this. So the only thing I need to do is change my minus sign to a plus, and that will give me my upper value. So my confidence interval for the mean tensile strength is 228.3 to 256.1. Okay, so I showed you how to find the t-value. Sometimes we do need to know how to get that t-value, and again, it's important to know the syntax for inverse t. It's the area to the left and the degrees of freedom. Now, the calculator has built into it the entire function that will allow you to find the confidence interval. So let's take a look at that as well. I'm going to go to Stat, and I'm going to use my left arrow to get to the test menu. And we've already established that we want to do a t-interval. That's option 8. You can either arrow down to option 8 and hit enter, or if you remember that it's option 8, you can just go on and select 8 to get to that menu. Okay, I have stats highlighted because I'm given the summary statistics, the mean, standard deviation, etc. If I had a list of data in my calculator, then I'd want to highlight data, and the calculator would calculate the mean and standard deviation for me from the data. Okay, my sample mean, I believe, is 242.2. Okay, our sample standard deviation was 70.6. Sample size is 72. And the level of confidence for this one is 90%. Okay, I don't have to find that t-value because the calculator knows how to find it. It can compute the degrees of freedom by subtracting 1 from the sample size. So I just put in the sample size, not degrees of freedom. And I tell it all the other information. Now I'm going to hit enter on calculate. And we get 228.3 to 256.07, which is what we had here. 228.3 to 256.1. So yes, I would use the built-in function on the calculator to get there, but sometimes we do need to use or be able to find that t-value, and that's why we would use the inverse t. So make sure you know how to get it so that if you need to, you can get it separately from everything else that's built into this function. But if you want to be most efficient, we'll use the t-interval procedure on the distribution menu.